Let's take a look at this example. We have 81 and 36. These two numbers are perfect squares. I can rewrite them as 9 to the second power minus 6 to the second power, and I simply copy a minus b to the second power. Now I can use properties of exponents and rewrite this problem one more time as 9 to the second power minus 6 times a minus b to the second power. Now take a look. We have difference of squares. Okay, so in order to factorize this problem, we're supposed to use the formula for the difference of perfect squares. The formula says x squared minus y squared is equal x minus y, x plus y, where 9 is going to be my x and 6 times open parenthesis a minus b is going to be my y. So I'm going to look at this formula and rewrite this expression. This is going to be equal 9 minus 6 open parenthesis a minus b times 9 plus 6 open parenthesis a minus b. Next, please notice that I have 9 and 6. The greatest common factor for 9 and 6 is 3. That's why I'm going to factorize the greatest common factor. This is going to be 3, and inside of the parenthesis I'm going to have 3 minus 2 open parenthesis a minus b, and the same thing I'm going to do over here. I'm going to factorize 3. Okay, remember this is multiplication, this is also multiplication, so I'm going to have 3 plus 2 open parenthesis a minus b close brackets. 3 times 3 gives me 9, and I'm going to have inside of the parenthesis 3 minus 2 times a gives me 2a, negative 2 times negative b gives me positive 2b, times, remember I multiplied this 3 by this 3, that's why I have 9, and I'm not going to write this 3 anymore. I have 3 plus 2 times a is 2a, 2 times negative b is negative 2b. This is the solution to my problem. Let's take a look at this example. I have 4 and 9, and I have subtraction. 4 is the perfect square, 9 is perfect square, parentheses are squared, z is raised to the even power, okay, so it's also squared. That's why I'm going to rewrite this problem as 2 to the second power, because 2 to the second power is equal 4, open parenthesis, x minus 1 to the second power minus 3 to the second power, because 3 to the second power is equal 9, and I'm going to write z to the second power raised to the second power. Remember, anytime we have power of the power, we simply multiply these two powers in order to get this exponent. So, what are we supposed to do next? We're supposed to use the properties of exponents and rewrite this problem one more time. I'm going to have 2, open parenthesis, x minus 1, and everything is going to be raised to the second power. I'm using the properties of exponents. Minus, because I have 3 to the second power and z to the second power raised to the second power, I'm going to write this as 3, open parenthesis, z to the second power, and everything is going to be raised to the second power. Again, I used the properties of exponents. Now, I have difference of perfect squares, okay? Where this term is going to be represented by x, and this term is going to be represented by y. And I'm going to use this formula right now. So this is going to be equal to, open parenthesis, x minus 1 minus 3z square times 2, open parenthesis, x minus 1 plus 3z square. Now I can distribute this 2 into the parentheses, and I'm going to have 2x minus 2 minus 3z square. 2 times x gives me 2x. 2 times negative 1 is negative 2 plus 3z square. And this is the solution to my problem.